All right. Welcome to today's episode. I just want to say thank you for everyone who has subscribed to this point. You have made this video possible. Today, we're going to run 512 and beyond pods on a Kubernetes node. Now, as many of you might know, Kubernetes sets a soft limit at 110 pods. And you might even know that some distributions like OpenShift up this to 250. Now, there's a lot of confusion as to just how many pods can be run. And the reason there's so much confusion is the fact that it really depends on your pod. How many containers are in that pod and what those containers are doing. Are they all heavy file IO? Do they use a lot of CPU? It really depends. And then you have other resources like your CPU. Are you going to start to thrash it? Because remember, each one of those pods has more processes and your processor only has so many threads. And then even on top of that, you're going to have your networking. Does your node have enough IP addresses? So these are all the things that we're going to explore into depth to get you running more or even less pods per node. Because I would even stress that if you're running small nodes, you should decrease this limit from the 110. The 110 is a very safe, and that's what's considered safe, but I wouldn't consider all nodes worthy of running 110 pods for a lot of reasons. And CPU thrashing is one of them. If you're running, even though you might be running really small nodes, you might start thrashing your CPU and cause you problems you weren't expecting. All right, so let's jump into this and start building a Kubernetes node that will run 512 pods.
Channel.
Okay, so I hinted at the very first thing that we're going to have to do, and that is set up our hardware and our network. So for the hardware, I did a very, very simple setup where we have a single control plane and a single worker. This isn't a production, but it replicates production because the workloads are going to be separated from the control plane. The other thing that I did is these are all connected to the same switch that is connected to the same router. So there really shouldn't be any network latency to be heard of. And there's no other overlay network on top of that. So everything is as bare metal as possible. All right, so that's the hardware. The next thing was installing Kubernetes. Really quickly, it's a quick kubeadm install. And we installed Calico for the networking. And this is the very first thing that you're going to have to do is you want to make sure that you have a pod network scheme that gives more than 500 IP addresses to each node for pods. So let's set this up really quickly. First, HTOP, just to show you, we have 24 cores and 126 gigabytes of memory. So that's not a problem. As you'll see here, my pod CIDR is the /16. So I have plenty of network IP addresses, and that's not going to be a problem or limiting factor. So here we go. We're going to set it up just really quickly. Usually this takes a little bit longer, but movie magic right here. All right, now that it's all set up, we're just going to copy over the kubeconfig files really, really quickly so that we can talk to Kubernetes. And now that we have all of that set up, it is time to go ahead and set up Calico, which is just two very easy, quick commands here. Links for this is in the description below if you want to use Calico yourself. All right, so now that Calico is up and running, we can go ahead and watch for it, or it's deployed, not running. We're waiting for it to be running now. And we're just going to fast forward really quickly. And now it's running. All right, so now it is time to go ahead and set up my local workstation. So I'm just going to scopy the kubeconfig file over so that we can use it from my desktop and not SSH'd into the control plane server. So I'm just copying over the kubeconfig to a special file called the 500. All right. Now that that's done, let's go ahead and set up the worker node. So kubeadm prints out a way to join a worker node. So we're just going to run this really quickly on the worker node here. And of course, you have to be a privileged user. So we're going to fix that really quickly. And we're going to run this, and it won't take too long. Now, what I want to talk about is what I'm running. I'm running the MySQL WordPress example from Kubernetes. And all you have to do is kubectl apply -k. And that's really easy. It's using customize. That's what the -k instead of -f is for. And it just deploys a WordPress front end with a MySQL backend, which I thought was a good general example. And then at the very beginning, I just scaled it to 250 replicas because that should fail, because by default, it only supports 120. And as you can see here, we have a lot of pods in pending. A lot aren't running. Now, a lot are running. You can see that quite a few are running, and that's awesome. But we have some that aren't running. Let's go ahead and describe one of these that are stuck in pending. So if we go down here and do a describe on this pod, you'll notice that it tells you one of them has too many pods. The other is the control plane node. So this one has too many pods running on it. And this is purely a kubeconfig issue, or a kubelet config issue, not kubeconfig. So let's go ahead and fix that. We're going on to the control plane node. We're going to fix it on both, but I'm just demonstrating it here on the control plane node. You actually want to do this on the worker node as well, but I didn't actually video that. So when you run this, what you want to do is find out where your kubeconfig is stored. What you can do is run the status. You can actually pass this as part of the arguments, but I don't recommend that for multiple reasons. So pipe it on to less so that you can get the whole thing here. And we can see that varlib kubelet kubeconfig.yaml is where the file is stored. All you have to do is vim into this file. And now you can add the configuration for what we want to do. You can pretty much add it wherever. I'm adding it right here. And we want to set the max pods to 250. This way our deployment would work. For my case, I'm setting it to 550 because in the end, we want to run 512. All right. Now, there's a couple other things that you can set here. And why you want to set them is because there is actually rate limiting that Go performs. And this just says how often your nodes can talk to the server. And the reason this is important is that by default, it's 5 requests per second. And if you have a lot of namespaces and a lot of secrets, this just doesn't work. And so you're going to want to update those as well. So let's update them. The first one that you're going to want to update is called Kube API QPS. And we'll set this one to about half of whatever we're going to send the burst to. And so we'll set it to 25. You can probably set this to 50, no problem. The next one is Kube API burst. And this is how many it can burst to for a short period of time. And we'll set that to 50. Again, these aren't like numbers I'm telling you to use. These are numbers that I used that made it work quite well. Another option that you can look at here is you can also set how many pods per core. And so this is a whichever is less. So if you have max pods, it uses how many pods per core, unless if it hits max pods, and then it uses max pods. So if you had 3 cores and you had 1 pod per core and a max pod of 550, it would only allow you to run 3 pods. So that is something else you can look into to help kind of dynamically limit so you don't thrash your CPU. And you could set this. Now, I'm not going to do that. So let's go ahead and delete this and save this and run our workload. Now, if you update the kubelet config for systemd with a new argument, you're going to actually have to do the daemon reload. But since we just updated the config file, all we have to do is sudo systemctl restart kubelet. And now our kubelet can run more pods. Now I'm going to do this on the worker really quickly. And now we're ready to scale our replicas. All right, so here we have the command. All we're doing is the deployment WordPress, scaling it to 512 replicas. It responds immediately because the API server says, yeah, we'll do that. And it changes the file and that succeeds. That doesn't mean you have 512 replicas right now. Let's check it out. If we do a line count here, we are only up to 82 at this point. So it takes a while for this to work. Let's check out how our computer is doing. You can see we have a high CPU load here on the worker node. And if you watch its memory, the memory is slowly going up as it adds more and more pods. So it's working, it's going, and it takes time to add that many, especially if they're all on the same worker. Now, if you had 100 workers and you scaled it to 512, this would actually be much, much faster, as that 512 worker nodes would or those 100 worker nodes would each be able to stand up one at a time. And so that's what you're experiencing here. We only have 1 worker. All right, so let's check. We have 529. The reason this is high is you notice the -A, and the -A is from all namespaces, which includes the system namespaces. And so there's actually some pods inflating this number. All right, so here is all the pods that were running. Our 512 for 512 fantastic subscribers. Thank you, guys. Now let's take out the -A's to get all of the mess out of there. And you'll notice here we have 514. The reason we have 2 extra is because there's the MySQL as well as an empty line, and WC is just counting lines. It's not intelligent here. So we actually have 512 of the WordPress front end running. All right. Thank you for sticking around and watching me run 512 pods. None of this would be possible without you guys. So thank you, everyone, for staying tuned, watching, and seeing how this is done. That being said, don't worry, this won't be the last video. My interest has been piqued. My desire to push the most performance we can out of a single node has been intrigued, and we will continue to see what type of performance we can get out of a single node, as well as not just performance, but proper utilization. You don't want to leave resources on the table. If you have a very beefy machine and your workloads are very lightweight, you don't want to leave that unutilized resources out there. So let's continue looking at the architecture of Kubernetes and how best to utilize the resources in our clusters. All right, so if you liked this video, if you liked performance and scale and understanding utilization, go ahead, like and subscribe. If you did not like this video, go ahead and hit that subscribe button, stick around and see if these videos get any better for science.